Hello friends, welcome to Suresh Aggarwal's Mathematics Shortcuts. Quadratic equations and quadratic polynomials. Factorizing the quadratic polynomials which have large coefficients has always been a difficult task for the students. I get so many queries on my WhatsApp and other social media platforms how to simplify the middle term splitting. And in this video, I am going to tell you something very special, and following these rules which I tell you in this video, you will be able to factorize any quadratic polynomial like very large coefficients. Here you can see there is a 44 also, and in subsequent questions I will be taking 2-digit coefficients and even 3-digit coefficients also, and you will see how a little smart work will help you in factorizing all these polynomials very accurately and in less amount of time. Very helpful for all the school students who are studying in class 8th, 9th, 10th level, and cracking multiple choice questions will be really easy if you follow this trick. So if you have not clicked the subscribe button till now, please do it now, and also click the subscribe button along with the bell shaped icon so that you keep on getting all the notifications of the future uploads. Watch the entire video to learn the concept, and then put in 2 hours of practice so that you feel comfortable with this concept. So let's go. The first thing is the coefficients are very large and middle term splitting is difficult. So let's simplify the middle term splitting process first. Before that, I'll tell you one step which will help you in factorization in just how many? 2 steps. That's it. See, here we have 5x square, right? So the first thing I am going to do is to have 2 factors in the brackets, and both the factors, just ignore this square here, and you have a 5x, and so I'll write a 5x here and a 5x here. Now, what is the second part? Now these are now the factors. We will have one more step, after which you will have your final answer. Now the middle term splitting part. So we all know whenever you have a quadratic polynomial like this one, we have to find 2 numbers or 2 integers whose product is the product of the first and last coefficients, and whose sum or difference is the middle number here, -9, right? That's a very difficult task, right? So let's simplify this. 5 times 44. I'm just ignoring the negative sign as of now, okay? So I want to split these numbers or this product into 2 factors whose sum or difference is 9, okay? So 44 and 5 is not going to give me a 9. So what will I do? 5 is a prime number, I'll keep that as it is. 44, I can break it down as 4 times 11. That's the easiest factorization of 44, right? Now let's see if we regroup these 3 into 2 factors whose sum or difference is 9, my job is done. So what about combining 4 and 5, which gives us 20, and then having 11 as it is? Now can we get a 9 using 20 and 11? We can, right? 20 minus 11 is 9, and that works. So 20 and 11 are going to be my factors, but what about the sign? I need a -9 here, right? So the larger one will be negative and the smaller one will be positive. Now these 2 integers, -20 and +11, I'll have to write here in this second part of each bracket, -20 and +11. You can swap them, you can write +11 here or -20 here, that doesn't matter. The order in which you write the factors, it doesn't matter in quadratic polynomial factorization, right? Now, is that the final answer? Not at all. I can see a common factor here in this bracket. The highest common factor between 5x and 20 is 5. So what will I do in this step? I will eliminate the HCF from each bracket. Now this is the important step. So 5x and 20, if I divide both of them by 5, because 5 is the highest common factor, this 5 will get cancelled, so I will have an x here minus 20 upon 5 is 4. Now you see there is no other common factor in the bracket, and 5x plus 11, I don't think there is any common factor here. So 5x plus 11 will be retained as it is, thereby giving us the factorization of 5x square minus 9x minus 40 as x minus 4 and 5x plus 11. Now this is the first example, and I'm sure most of you will say this is quite lengthy, but as we progress through the video and I'll show you more examples having larger coefficients, you will realize that the method is not difficult. It just takes time to practice it and put it in our behavior. Let's have one more example. Here you can see now the coefficients are all 2-digit coefficients, whether this quadratic polynomial or this quadratic polynomial is to be taken up. Now 21x, so I have to ignore the square, right? So I'll put a bracket starting with 21x, close it, and then another bracket starting with the same number 21x and then close it. Now what about the factors? 21 times 15. I'll write here 21 times 15, and I need to get it 26. Now 21 and 15 is not going to give me a 26. Even if I add them, I get a 36. If I subtract them, I get a 6. So this is not going to work. Now I have to break it down into smaller factors. So 21 is 3 times 7. I can write 3 times 7 here, and 15 is 3 times 5. See, I have broken it down into smaller factors. Now can we regroup them and get two integers which on addition or subtraction gives me this number 26? Of course we can. Just check 7 times 5, 35, and 3 times 3, 9. 35 and 9, the difference between these two is 26. And since this is positive 26, the larger one will be positive and smaller one will be negative. So plus 35 minus 9. Just write them here, plus 35 and minus 9. You can write minus 9 and plus 35 also, no worries. And now remove the highest common factor from each bracket. If you check here, 21 and 35, the highest common factor is 7. So if I divide this by 7, I get 3x. Divide this by 7, I get 5. In the second bracket, 21 and 9 are divisible by 3. So if I divide this by 3, I get 7x. And if I divide this by 3, I get 3. And so the factorization of 21x square plus 26x minus 15 is 3x plus 5 and 7x minus 3. Now see, the number of steps have reduced, and I think you will be feeling more comfortable. I'll take 2 or 3 more examples with larger coefficients now, and we will try to eliminate the steps also so that we can reduce the time to be taken for factorizing such polynomials. Here we have negative 11. So in the beginning I have to ignore the 2 here, the power. So I have a 15x and my factors will begin with 15x. Now the second part, 15 times 56. So 15 times 56. 15 and 56 is not going to give me 11 in any case, right? So what do I have to do? I have to split it into smaller factors. And those smaller factors obviously are 15 is 3 times 5 and 56 is 8 times 7. 8 7s are 56. So if required, I will break 8 also, but let's recombine these. I want a 11. So if you do 5 and 7, this is 35, and when you do 8 and 3, you have 24, and see the difference between 35 and 24 is 11, and it works, right? So negative 11 means larger one is negative and smaller one is positive. So minus 35 and plus 24. So you can write them in any order in the brackets. Negative 35 and plus 24. Now finally remove the common factors, the highest common factor. 15 and 35 divisible by 5. So this becomes, divide by 5 means 3x. Divide by 5 means 7. 15x and 24 I think divisible by 3. So if you divide this by 3, you get 5x, and divide this by 3, you get 8. And since there are no more common factors in the two brackets, this is the factorization of the huge polynomial 15x square minus 11x minus 56. Likewise, we can go on and solve so many different problems. I have taken two more problems here. You can see we have a 91 here and a 117 here, and still the method works well. Let's check. So I'll be little quicker now. 12x, because I have to remove the square, and then 12x in the second bracket also. Now 12 times 91 is, I don't want to multiply these, I want to get a 64, right? So I'll factorize them further and break down 12 as 2 times 6 and 91 as 13 times 7, right? 13 sevens are 91. And now let's combine 2 and 7, which gives me a 14, and combine 13 and 6, which is 78. Now the difference between 78 and 14 is 64, see? And so since this is negative, the larger one will be negative and smaller one will be positive. Now that is the only thing you need to understand here. If you understand this step, then the factorization is not going to consume more than 10 seconds. Okay, so negative 78 and plus 14, and now remove the highest common factor. 12 and 78, I think they are divisible by 6. So 6 2s are 12 and 6 13 times is 78. Here we have 2 as a common factor, so 6x and then plus 7. And here we go, the factors of this huge quadratic polynomial are 2x minus 13 and 6x plus 7. Likewise, you have the last question there, and let's perform the same steps here. So this starts with 40x and the other factor starts with 40x as well. Now 40 times 117. Now 40 times means, now this is 4 times 10, right? And this is 13 times 9. 13 nines are 117. So let's group them now. I need a 38. So 10 times 9 is 90. And 13 times 4 is 52, and the difference between 90 and 52 is 38. Negative 38 means larger negative and smaller positive. So write negative 90 and positive 52 in the two brackets and remove the highest common factor. 10 is the common factor here. So this becomes 4x minus 9. And what is the common factor here? I think they are divisible by 4. So 4, 10, x and 4 13, so plus 13, and that is the prime factor, the factorization of 40x square minus 38x minus 117.